We have a hot air balloon, we have a spring-loaded gun being fired down into a precipitous canyon. Now, today we didn't put any numbers to this. The balloon was somewhere, the spring had something, it's a whole lot of questions left perhaps unaddressed. So let's start trying to put some numbers to this and figure out what we can and cannot say, and see what comes of it. So, start off, let's say that the balloon is 100 meters above the canyon floor. That's pretty far up there. Let's go 10 meters. 10 meters is better. Let's say that the bullet has a mass of 0.1 kilograms. Let's say that the spring has a spring constant, call this K, remember. Let's say it is 100 newtons per meter. And let's say that the spring has been squished an amount, delta x, which will be 0.1 meters. So that's a lot of information. What does it buy us? Well, before we had said that in our initial state we would have elastic potential because we have a compressed spring, and we would have gravitational potential because we are so high up. Now we can say how much of each we have. We can say that we have that our initial elastic potential energy is 1/2 k delta x squared. And we can put a number to that. We can say our initial gravitational potential energy is mgh. And we can put a number to that. So now let's say we get down to the bottom of our canyon, all the way down here, and the bullet has bounced a bit, and it is about to hit the ground. Not quite hitting the ground. Why is this not letting me erase? Alright, not quite hitting the ground. You're just going to have to believe me on that. And let's say that it has some velocity that is, and we're going to hope that I don't make up a number that doesn't work, root 2 GH looks like 10. Alright, so 5 meters per second will be the final velocity right before it hits the ground. So then our final energies, well, this 10 meters was probably from here all the way down to the bottom, actually. Let me just edit that slightly. Anyway, so our final energy, well, it's not above the bottom anymore, so H would be 0. The spring is not compressed anymore, so delta X would be 0. All that we would have is kinetic energy. And we said that that is going to be 1/2 mv squared. So now, what we can do with this is say that the final energy minus the initial energy should be equal to the work. This is our first law of thermodynamics, conservation of energy at its finest. So our final energy should be 1/2 mv squared. Our initial energy should be 1/2 k delta x squared plus mgh. And that will equal the work. So now on the test we said that it lost some energy when it bounced into the rocks. So what that means, we think this should be negative. Because our change in energy should be negative. We should end with less energy than we started with. We lost some of it along the way. So let's check. We have 1/2. Oh, I'm going to need a lot more space for this. Alright, so work is equal to 1/2. We have that m is 0.1 kilograms. We have that v is 5 meters per second squared. We have that k is some outrageously large number, 100. We have that delta x is some outrageously small number, a tenth. And that's squared. And we have minus again because the minus sign distributes. 0.1 times 10 times 10. So let's see here. So this is 1/2 times 0.1 times 25. This is, so a tenth times a tenth is 100th, so this is just a half. This is 10. So this is, so 2.5, half of 2.5 is 1.25 minus 10.5. So the work is minus 9.25 joules. Indeed, negative as we thought. So, this is a very complicated kind of example of a problem like this. It has a lot of things going on. There's work involved because the energy we start with is not the energy we end with. And it has all three kinds of energy in play. So hopefully, this is as complicated as these look, but we had to do everything in this. We had to calculate each type of energy we were worrying about. We had to look at what conservation of energy looked like and ask, how did the initial energy and the final energy stack up? Was there work done in the middle? And we had to churn out a number at the end. So, hopefully this gives you some inspiration as you start looking at the homework for this. Good luck!